So, uh, okay. Uh, so, good evening.
Good evening.
We are going to have a session of machine type communication towards 6G. The resource person is our very own engineer Thushan Sivalingam. Engineer Thushan received the B.Sc. honors degree, specializing in electrical and electronic engineering from the University of Peradeniya, Sri Lanka in 2015. Double degree M.Sc. In wireless communications from the University of Oulu, Finland, and the University of Peradeniya in 2019. He held a planning engineer access network planning for the Eastern region, a position at Dialog Axiata PLC Sri Lanka from 2015 to 2018. He is currently a doctoral researcher with the Center for Wireless Communication. His research interests include machine learning for PHY-RAN and massive machine type communications. He has published several technical papers in top tier IEEE conferences. Also, he is a technical program committee member of IEEE VTC 2022 Spring and 5th SLAI International Conference on Artificial Intelligence 2021. Over to you, Thushan.
Hello, everyone. So, hope I can start the session. So, after the presentation and all, we can discuss about the question and answer. Meanwhile, if you want to talk something during the presentation, okay, it's free to ask the questions. Maybe put in the chat box as well. Okay, so I'll start the presentation. It's about massive machine type communications towards 6G. So massive machine type communication is already existing technology from 5G onwards. So there are many applications it's connected with. I think most of us already using the massive MTC applications and the communications, but to the next paradigm will be a totally different shift, and it will be more beneficial to the digitalizations of the human. So in this point of view, I plan to cover the contents are like initially the introductions, what is massive machine type communication, and massive MTC drivers and use cases, requirements and service classes. So in the second portion, I'm going to cover for the 6G point of view, that means the expected requirements. So then the enabling technology. So in here, it will be more technical aspects. What are the things we need to be done, and what are the ongoing researches, and what are the requirements. So finally, the conclusions. Okay, so come to the point. So what is machine type communication? What is massive machine type communication? So massive MTC, it's a subclass of machine type communication. So in here we can say there are machines involved at the same time, human also involved in this communication. So yeah, so here the communication between machines over wire or wireless, but in this presentation we are going to talk about the wireless scenario only. And specifically the data generation, data transfer and actuations takes place without human involvement or very minimal amount of human involvement. So generally it's a kind of one of the advancement of the IoT. So IoT is now everyone's using, we are already in the IoT domain. So from Internet of Things to Internet of everything brings a massive surge of smart connected things. In IoT point of view, we can say like massive MTC, massive IoT devices and critical IoT devices, and industrial IoT and broadband IoT. There are 4 main categories there in the IoT point of view. So in massive MTC comes like billions of devices in the network. So the consideration of the area may be a kilometer square or for a country or something like that, but there are many devices. So the devices in the sense, it will be a sensors or some actuator. So it's not going to be a very big machineries or something. And it's a kind of key, a key advancement from Internet of Things. So here the two pictures clearly shows what's the difference. So here the massive MTC, it's mostly low cost. Low cost in the sense the sensors may be low cost and low energy. Most of the applications need very small amount of energy and small data transmissions and massive numbers. So here the main criteria comes like how we can design a very low energy devices. For example, these applications in the smart building. So most of the smart buildings have many sensors to control the lighting and the temperature and fire alarms. So everything will be the sensors. At the same time, uh, can I think there are some sound gap. Can you mute? I think. I, excuse me. Yeah. Okay. Okay. Yeah. Thank you. Okay. So come to the massive MTC scenario. For example, logistic tracking and fleet management, or some smart metering, smart agriculture. So the detailed description will be there in the later presentations, and capillary networks. So for example, the capillary network may be the new word. It's a kind of the local network that uses short range of radio access technology to provide a local connectivity to the devices and the things. And the critical MTC comes. Here the requirements are totally different. So here the ultra reliable, very low latency and very high availability. So for example, based on the application, you can get the picture. It's a remote healthcare and traffic safety and control and industrial applications and control. Like for example, those industrial applications kind of a manufacturing process or something. Therefore, there's a high requirement of ultra reliable and the remote manufacture and training and surgery, something like that. So mostly that healthcare and traffic management comes under the critical MTC. So therefore, there's a reliable is very high, very important point in the design of critical MTC. Okay, so now we come to the questions like why we need 6G. So we already have a 5G, we have internet, we have devices. So then there's a questions why we need the new technology. So the 5G new radio already designed to support massive MTC and critical MTC applications. So therefore, from now onwards, I think from the release 3G release 17 onwards, can be use the new 5G radios and all. But the thing is, the current trend of digitalization require high necessities of MTC, which cannot be fulfilled by 5G. Maybe at the current situations, maybe we maybe not need everything, but maybe in the next 10 years, the requirement definitely will change. So human life mostly goes toward the digitalization. So also there's a requirement to design a technology for the future. So based on this concept, we need something totally different technology to achieve all the requirements. So in here, the key performance indicators of 5G is reliability, latency, and scalability. So then what about 6G? So it's maybe continuation with the reliability, latency, scalability, and there should be something different. So in here, there are two different things comes. One is the energy efficiency, other one is the end-to-end performance and measure and sensing. So here, because the energy efficiency comes because there will be a billions of devices, so then we don't have much energy at every time. So therefore there's a proper way of designing and optimizing the energy efficiency. So in this picture clearly tells what are the 6 research visions. So it comes in the sustainability, business, and technology. I think you maybe refer United Nations Sustainable Development Goals. So it's one of the 6 also can be a part of the sustainable development goals. So therefore, there's a huge requirement to design a new technology. So then I can tell the critical drivers towards 6G. So one is in a society point of view, digital inclusions by global coverage. So connectivity is the key to satisfy the, as I said earlier, the UN Sustainable Development Goals to need to digital societies. Current terrestrial technologies with evolutionary features need to be complemented by specific remote area solutions, including satellites. So there is a requirement to connect the entire world. So there are some places without any coverage or network. So it comes the first criteria. Then the business. So this is something, the new business model, new ecosystem, and distributed business models needed for the 6G, like new verticals create new ecosystem and new trends, something like that. So then there's a security comes in a point. So for example, in Europe and other countries start to talk about the privacy and the security. So therefore, in the next generation wireless need to be addressed the security as well. So it's explained in a verticals of with new stakeholders and emerge of large number of new players providing different network elements, for example, critical applications, and operate in different parts of the network set of privacy and security requirements. So those things are comes under security. And the main thing is the radio technology, super efficient connectivity at high spectrum bands. So we have some limited band. At the same time, we need high spectral efficiency. So therefore, there is a high requirement to design something totally new to achieve the targets. For example, extreme speeds, reliability, low latency, and localization sensing accuracy can be achieved. So we maybe know that current position and localization can be done with the GPS, but that's not enough. That's in the meter range. So we need some centimeters or more than that kind of accuracies. And maybe locally in rather short range network utilizing existing frequency bands, and new ones may be over 100 gigahertz. So can be a possible new radio technology. At the same time, the main thing comes the AI technology. Smart AI enables networks and applications. AI is artificial intelligence. So networks and applications become intelligent. So self-learning and context-dependent edge intelligence is the kind of key technical enablers and challenges. And for example, here the cloud solutions also comes under the picture. So most of the future devices and all have the self-learning capability, and it will adapt to the environment, and it will play the role for the human digitalization. And then the standards. So global collaboration and standards. Yeah. So here the thing is, when we talk about the global networks and 6G, there should be some standard ways to communicate. So every countries have different rules and regulations, and different operators and different products have the different standards. So 6G collaborations forming new geopolitical landscape. It's a new standard is introduced after every 10 years, or business reshaped in every 20-year cycle, for example. So spectrum regulations principles changing. So let's say 25 plus years it changes. So therefore, there's a standard ways to define how the 6G will achieve the targets and all. So from this point of view, you maybe get the point, like why we need 6G and what are the main aspects going to talk in the 6G point of view. Okay, then I come to the massive MTC driver. So now we got the picture what is massive machine type communication. So in 6G point of view, what are the main things we are going to get? So first one is autonomous mobility and connected living and factories for the future, and digital reality as a frontier technology. Another one is towards zero world, data is as a new oil. So these are the things considered for like a massive MTC driver. So clearly, it's autonomous mobility in the sense intelligent transport systems that require reliable communication. That means increase the sensors and edge processing will play some role. For example, you maybe heard about the Tesla's new autonomous cars, and the level of now I think they are moving from level 3 to level 5. So the fully autonomous without any human involvement will be the player. So in those kind of scenarios, there will be lots of sensors will need the information to provide to the vehicles and transport system. At the same time, there's unmanned aerial vehicles and unmanned vehicles start to play. So in those scenarios, there's a 3D connectivity landscape we need. So like, how about the obstacle avoidance, how to do a proper path, proper planning for the autonomous mobility. So those things comes as a main one of the massive MTC drivers. In second, the connected living. So ubiquitous connectivity anytime, anywhere will facilitate new possibilities at home, in entertainment, health, and work, and provide citizen services like super smart cities. We already talking about the smart cities. Now we are going to talk about the super smart cities. So the communication and connected will be there in anywhere and anytime. So those are the main points. So in that point of view, we need to facilitate the global coverage to connect the entire world in some new paradigm. So, and just yeah, and the third one is the factories of the future. So the transformation shift in production industries. So like industry very first evolutions onwards. Now industry 3.0, 4.0. Now we are going to talk about the industry 5.0. So in the industry 4.0 specifically have the machines with some sensors. So in 5.0 will be something totally different, that the machine with some intelligence, and there will be human also involved. At the same time, because of the involvement of human and the machines, there will be a much more devices in the environment to control the functions and the designs. So therefore, the novel human machine interfaces are enabled, like maybe not in the first step, like humans start to talk with machines. In future, as a evolutions of 6G, there's a high chance of human can directly, you know, facilitate with machines to make the future factories. And a digital reality as a frontier technology. So now everyone's need some, entertainment and different real world scenarios with within the same place or home or somewhere. So for example, after the pandemic and all, we mostly start to live in a home, and we don't have much access facility to go everywhere. So the augmented and virtual mixed realities will evolve from a market application to world spec adaptations. So that's needed new use cases and use experience enabling new, novel, and efficient main machine interfaces. So to achieve all these things, we need a high throughput and high amount of devices. So that's comes in the massive MTC drivers, because like there are a lot of inputs need to be given for the scenario to design the real experience for human. So another one is the towards a zero world. So here the zero place, the in massive MTC for 6G, there will be many places you maybe heard about the zero world. So in the zero, say zero in the sense like zero energy or zero touch or zero latency, zero error. So it can be many things. But first thing is about the zero energy technologies. But it's maybe hard, but there's a possibility to design something like very high performance at very low energy consumption and zero latency, but it comes under the ultra reliable low latency communication with very low latencies and zero error. That means like when we are going to talk about massive devices and human involvement and very crucial application, there should be some error. So in the later slides, I'll tell about that what are the numbers point of view. So because all the things are needed for enabling the real-time control, because like if it's pre-designed or pre-recorded, then there is a chance to correct errors and latency. But if it's a real, then everything should be synchronized in a time manner. And data is the new oil. Yes. So when artificial intelligence and deep learning, machine learning start to play, then data is the main important. At the same time, data privacy also comes with the data, but the collection of very large amount of data will definitely provide a much more different experiences. For example, you maybe see advertisements. Now, when you search something in a Google, within a half an hour or something, you can get some advertisement in your Facebook. So it's a kind of data process. So therefore, in the next generation's wireless, it needs lots of data to have a specific design of applications and the solutions to every human separately. So these are the main drivers for massive MTC. Then I'll come to the massive MTC use cases, where the main areas of the use cases can be. Okay, so first one is connected industries. As I said, Industry 4.0 coverage, advanced manufacturing techniques with data-driven technologies and AI tools to improve the operation and performance efficiency. Enterprise, but 5.0 requires massive connectivity. Therefore, to cater everything, there is a requirement for Industry 5.0 of massive MTC use cases. So therefore, the connected industries will come. So second is a swarm networking. So the autonomous vehicles like self-driving cars, autonomous guided vehicles, and unmanned aerial vehicles have started finding application in different use cases. So in here, the swarm is a kind of group of such devices collectively performing the task distributed fashions, achieving an overall mission objective. So here, like, so in the concept is like those vehicles or those UAVs in their self, they create a group. So they'll exchange information. So some edge processing will be there. So then they'll have the intelligence to take the decisions. What are the next step they can go? There are some power optimization. There are some, positioning, how to do the task. So depends on the requirements or depends on the scenario. The swarm network can be created and they'll get the information, they'll exchange the informations by themselves and do the tasks. So that's the kind of swarm networking. And the personalized body area network. So nowadays you maybe see there are a lot of wearable devices. We like to wear smartwatches and earbuds and part of, there are many small gadgets we start to use. So in further advancement can be our clothes, can be some sensors with some smart devices, can be with the massive MTC scenarios. And there is some research going on to implant as a skin patches or bio implants with sensors to provide what are the requirements. So depends on the person, it will be different network. So therefore it will be a more personalized based on the requirements and your network and your home. So that also comes under massive MTC scenario. And as I said earlier, the zero energy IoT. So aim to reduce their power consumption. So wireless energy transfer start to talk in the sense like, so here the wireless energy transfer is still not in the standardization, but it's very large amount of research going on how to enable the wireless energy transfer, what are the technologies, and backscatter technologies are fundamental enablers. Almost end of the slide, I'll talk about the backscatter technology with more detail. So another one is the Internet of Sense. Internet of Sense will be allow humans sense into interact with machines by enabling haptic interactions with sensory or perspective feedback. So this is initially looks, it's need a lot of works and technology to enable the sense, but there's a possible that human can directly transfer the information or requirement to the machines. For example, like the new bright, I'm not exactly sure the Elon Musk's new project. So those are the things kind of the start of the Internet of Sense. So we start to provide the sense through the machines and human will be there as a part. And so it's a kind of totally different paradigm of sense. And the smart contract. So here that the current contracts may be not valid since there are a lot of issues related to that and the scalability and the new challenges we face, for example, the pandemic and all. So therefore, the distributed ledger technology, it's called DLT, allows value transaction between parties through a decentralized trust. For example, the smart contract can be applicable in the SWAM network as well, because there are a lot of devices and the UAVs connected, so they need lots of information to process. So in that case, their smart contractors start to play. So they have some trusted contracts between the devices, and they'll exchange the information. So these are the main use cases. Okay, so then comes to the massive MTC requirements. So in here, it's like there are several categories. For example, like dependability in industry scenarios, close-up control applications will require end-to-end reliability up to 1 minus 10 to the power minus 7. So you can calculate and see what's the kind of accuracy we need to maintain the close synchronization at end-to-end latency as low as 1 millisecond, for which per link reliability of around 1 minus 10 to the power minus 9 and user plane latency around 0.1 millisecond may be required. So these are kind of initial description about how the uh, dependability will be there. And second one is about the efficiency. So in terms of 3D connectivity and supporting up to 100 connections per meter square. So in terms of energy efficiency, the ultimate 6G vision is to achieve zero energy machine type devices. A third one is scalability, the global connectivity, massive scalable 3D connectivity. So here, like alongside the existing ones, the KPI is becoming more narrow down and unique. For example, the age of information and information transfer and positioning. Positioning comes. So as I said earlier, the current positioning system, it may be not sufficient to provide the ultra reliable requirements and very narrow down requirements of massive MTC. So therefore, different positioning techniques are kind of involving. They are the base station information and the UE information at the same time with satellites start to play some of their information. So collectively, there will be new technology that start to do the more precise positioning. And then the throughput, the spectral efficiency. Yeah. So in the throughput point of view, the current 5G throughputs may be enough for normal our usage. So day-to-day browsing and the videos for everything, current throughput is maybe enough. But for massive devices, so therefore there are lots of devices will be there. So even every devices consume small amount of data, but collectively it's a more amount. At the same time, there's a spectral efficiency comes. So that means like there are a lot of vendors will be there. So how can we collectively achieve the spectral efficiency with sharing the spectrums, and there are new standard how to share the spectrums and all. So those comes under the throughput. And finally, the security, privacy, and trust. So the low cost authentication and authorization. So as I said earlier, some standard privacy and security start to play, like we need to pay a lot of money for that and not. But in massive MTC requirements for, as I said earlier, the smart contracts and all, they are coming a lot of latency, and the details will be there. So therefore, it should be very within a minimum amount of data and within a minimum amount of data transfer and all, with low cost authentication should be there. So in a nutshell, in the next slide, I can show some amounts. So here the key performing indicators. So here it's for all over the 6G requirements. For example, like some verticals and link data rate, latency, link budget, jitter, density, energy efficiency, reliability, capacity, and mobility. For example, like industry massive MTC, the link data rate less than 1 megabit per second, but latency 100 less than 100 milliseconds. But jitter may be 100 microseconds. The density like 100 devices per meter cube. So here we are talking cube because of the sense like there are some UAVs and drones comes to the play. So energy efficiency should be high and reliability 1 minus 10 to the power minus 6, and capacity uh, less than 10 gigabit per second, and the mobility also considered, but it's not applicable for all the massive MTC scenarios. For example, the uh, industries and sensors, there can't be much mobility because some machineries, production machinery may be stationary, so therefore that mobility may not be required. But in this scenario like intelligent transport system where there are much more devices and the future vehicle speed may be expected to high, so in the sense the requirements are kind of current trend of designing it's up to 240 kilometer per hour and industrial URLSC. So in this is the kind of different than industry massive MTC because here it mostly depends on the ultra reliable low latency communication. So as I said, there are some manufacturing process with human involvement and some smart surgeries and the so in those kind of scenarios, you can clearly see the jitter is very low, less than 1 microsecond, and the latency less than 100 microseconds, and the reliability 1 minus 10 to the power minus 9. So you can get the value. So very minimum amount of error can be there in the system, and mobility as I said earlier 240 kilometer per hour. And there's another case like total mobility scenarios that mean for fully transportation systems. So in that case, link data rates it's less than 100 gigabit per second, but energy efficiency nominal because it's there are different machineries come, so therefore there are some amount of energy efficiency there, but the capacity is 1 terabit per second, and the mobility is expected 1200 kilometers per hour. For example, some smart some electric trains applications can be there. And then the main thing, the e-health system. So in future there's a very high chance to we also going to experience the e-health system. So in e-health system you can simply see the reliability will tell the 6G's vision, so 1 minus 10 to the power 9. So very minor error can be there, and mobility also kind of 240 kilometer per hour. And another one is the energy sectors and the values mentioned here because like here there can't be any mobility, and also therefore the mobility not considered for the energy sector. At the same time, like in the financial sectors, the reliability is the main thing, and technology for the application. It can't be because like our requirements are differ, and the, based on the applications, these main KPIs also vary. So therefore, several specific design need to be done. And another one is about the public safety. So in the public safety also, you can see the density may be very low, 1 over meter cube, but the reliability should be very high and with high mobility as well. And the agriculture and agribusiness. So in future, there can be a possibility that agriculture monitored by sensors, and they'll start to decide that what are the changes to be done, what are the issues related to what are the issues related to the agriculture and all. So for example, like so in agriculture business, like density is like 100 devices per kilometer square will be there. Just yeah. So but in the reliability maybe 1 minus 10 to the power 7 because it's not crucial like e-health or ultra reliable low latency communication. So those are the things mentioned here. Yeah, just a minute, there is a question mentioned. Yeah, so yeah, what is jitter? So jitter is like there's a time delay of sending of data packets of your network connection. So what's the time delay of the data packets? For example, when you check in a network speed or throughput something in some application, it will show the jitter. So you can somehow get the idea. The delay, it comes in the kind of data plane and packet transfer scenarios. Okay, so then I go to the next slide. So massive MTC service classes. So I briefly talk about these, but still I'll explain that this part a little more. So uh, clearly, 60 service classes are proposed to classified in the white paper as follows. Like, so the details are followed in the white paper. I mentioned the source here, so you can see the clear detail about the requirements. So in here, there are dependable critical MTC and broadband critical MTC and scalable critical MTC and globally scalable massive MTC and zero energy massive MTC. So these are the kind of 5 different categories. So in the dependable critical MTC is like supporting extreme ultra reliability and low latency along with other measurements of dependability, for example, like security, as well as precise positioning, and can be seen the direct evolutions of 5G URLC. So currently there are 5G URLC applications, and it's a kind of evolve of the 5G URLC. For example, it can be in the autonomous driving. So dependable critical MTC comes for the autonomous driving, you can say. And another one is like broadband critical MTC. So supporting mobile devices with data with high reliable and low latency, but it may be not required for everyone for very high throughput. But there are some, because like current mobile phones start to support the XR and VR support. So in those scenarios, the data rate should be very high because like in if it's, for example, if you see a picture, it's in pixels, but when you see in the 3D objects and something, it's voxels. So the amount will be very high. So therefore information should be very high. Therefore the XR application, it need a very high data throughput. And the cloud gaming, so like you maybe see why the smartphones initially came with 60 hertz display. Now everyone's asked for 120 hertz display because of the gaming facilities, and people start to see, okay, that's a slowness, I couldn't see the image and all. So people start to ask very high gaming experience. So in those scenarios, and robotic aided surgery. So in those scenarios, the robots start to get the information from different places and start to decide based on the requirements provided by the doctors. In those scenarios, it comes under critical, because like you can see the criticals comes and transportations, health, and very crucial applications, only the critical MTC comes. And scalable critical MTC is supporting massive connectivity with high reliability and low latency. Example like critical medical monitoring and factory automation. So in here, it's like you can simply see the critical monitoring, not about the action. So when it's actions comes, so there's a broadband, but there will be a high data rate requirement is there. And the factory automation, yes, because like in the factory automation scenario, the devices and the machineries maybe can move very fast. Uh, there is a chance human also involved. So if it there, so then the error should be very less to stop the accident and facilitate the practically feasible solution in the smart factories. So that comes under scalable critical MTC. And another one is a global scalable massive MTC. So as I discussed discussed earlier, the UN Sustainable Development Goal is to kind of achieve the global coverage and also supporting ultra-wide network coverage throughout all the space dimension, including volumetric density of devices and the role of UAV swarms and non-terrestrial networks. It's a fundamental for enabling global massive MTC connectivity. So like here, the UAV swarms are like can be applicable. For example, like there are two different applications I can tell. One is like during the disasters and during some very hard time, there's a very high chance the base stations collapse. So in those scenarios, there's a information and alerts need to be given to the people. So the SWAMS networks are the kind of suitable for that kind of critical accidents or critical disaster situations. At the same time, UAV swarms are very suitable for providing them as a base station, UAV base station. So the UAV base stations will be to the kind of corner of the places. For example, like when you do a coverage planning and all, there's a corner in the place you can put a base station, but you need to provide the coverage. So therefore, the UAVs are the kind of suitable solutions to provide and fill that gap with minimum cost. Of course, there's a battery free charge and the facility maintenance will come, but those are the kind of apart from the requirements. But the main thing is about to provide the coverage. Then, of course, additional things need to be done. And the zero energy massive MTC. So massive deployment of energy efficient radios with exceptionally long battery life and network lifetimes. For example, soil monitoring and precise agriculture. So I can tell example like this, like you put like 10,000 sensors in your agriculture farm or something, and when there's a battery changing work, so just imagine there will be a workers need to go and change every battery and put it there. During the time there's a high chance of loss of information. They may be the sensors may be non-active for particular time, so they may be lost some of information. At the same time, there can be errors of replacing batteries, the second thing, and the labor cost will be very high. So therefore, the current trend and current requirements to kind of target like let's say 40 years of battery life, something like that. So if we have 40 years, at least it's kind of considerable. Okay, we can have enough time to do the changes. And also, since there are massive devices will come, the battery is a kind of main thing when we are going to replace the battery, or what's the point of view of having the sensors. At the same time, very hard to say we can put up direct electricity or something, because like there will be a remote area with massive amount of devices, so then it's very hard to provide the power consumption power from electrical point of view, because like those sensors need very minimum amount of electricity. So with all the consideration, the service classes are comes like this. And yeah, so in a one picture it's like that. So in here it's everything's are kind of connected together. So the drivers have the data, mobility, connected living, factories, digital reality, and towards real world. And it goes to the use cases like connected industries, swarm networks, and internet of sense, smart contracts, a personalized body area network, and zero energy IoT. So with the use cases, we can go to the requirements. So the requirements are dependability, as I said earlier, 1 minus 10 to the power 9. It's kind of one of the very crucial, and 0.1 millisecond latency, and efficiency, energy efficiency, end-to-end cost optimizations are not, and scalable. So how can we go for the entire global connections? And I think another one is a sensing, because these need for to provide the AI and deep learning solutions, the localization, accuracy, and positioning, and the throughput, so high spectral efficiency, and finally the security, privacy, trust. So now there is a trend of start to talk about the privacy security in all over the world. So therefore, the future wireless communication should address the low cost authentication and the lightweight, flexible, distributed solutions for the requirements. And the service classes in this picture clearly shows, for example, like in a dependable critical MTC, the precision should be very high and reliability should be very high, very low latency. But at the same time, broadband critical MTC, you can see the data rate may be medium. But for scalable critical MTC, for example, connected density, it's kind of medium, energy efficient medium. But globally scalable massive MTC, the connection density will be very high, but reliability may be in a medium. So it depends on the service class. So in the last picture shows the different variety of requirements of designing. So therefore, different technologies and novel inventions need to be done to satisfy the requirements. Okay, then I go to the in a technical point of view. So what are the enabling technologies? Novel innovations and enabling technologies are required to achieve the 60 vision for the MTC domain. Not only MTC, the entire domain. And the new solutions span different layers of protocol stack from efficient hardware design to the application layer. Okay, so in the enabling technologies, we can put like in a 5 different forms, like a holistic MTC network architecture, energy efficient MTC devices, global massive scalable MTC, and mission critical MTC, and privacy and security. So next, yeah. So in the holistic MTC network architecture, the today's portfolio of massive MTC, the right is radio access technology, and the architecture operations under the different MTC networks is extensively multi technologies and drivers. Like in here, there are no MTC oriented tracked radio access technology. So therefore, which can address the need of density significance of MTC application and use cases. Like this, there are no single MTC. It's there, like I said earlier. So and vice versa. In many environment, multiple radio access technologies and networks do coexist, thus forming a heterogeneous and multi-connectivity enabling network. And however, such environment is typically disjoint. The network often belong to different administrative domains. For example, by the examples, you can get the picture. Bluetooth is there, Wi-Fi standard is there, IEEE 802.15.4 standards there, LoRa bands there. So these different technologies have different standards. So therefore, there is a requirement to have a like specific massive MTC oriented standards which can accommodate all the standards. It's not easy, but there are a lot of work need to be done, because like every standard is going separately and the devices are separate, but in a general way of standard need to be done for achieve the high expectations, as I said earlier. So in here, there are some key trends. So current technology has the cell-based architecture. So the base station have the cells, and we are talking about the handover and a lot of stuff along with the cells. So the new technology, it can be a cell-free. It's there for like last 5 years, people start to do the research and all. There are some cell-free strips also in the industry start to apply. So there are no cells, but there's a controller involved, and the controller make the decision. So now the trend is there. Is it possible to do a cell-free architecture for MTC? So those are the kind of current trend of technology. At the same time, increased network heterogeneously. Like, as I said earlier, it's not sufficient to have only with the terrestrial network. So therefore, UAVs should be there, UAV swarms there, and unmanned vehicles there. So therefore, they increase the network architecture and interfaces less and dynamically formed network. Yeah, as I said earlier, if there's a proper infrastructure node, then it's a bit hard to change them. Depends on our application, because like the MTC mostly plays with different variants of application, the requirements. So therefore, the dynamical formation of the network need to be done, and different traffic patterns, of course. Earlier you can see the application depends on the data rates are totally different. So some have very high data rates and some have very low data rate. So if you provide the same for everything, it's sometimes it's unnecessary data, and we are kind of wasting the resources. In some application it may be not enough. So therefore, different traffic pattern analysis, and based on traffic pattern, the resource allocations need to be done based on the traffic patterns. and the wireless energy transfer. So it will be a kind of one of the key point to the architecture, how to optimize the energy in wireless point of view. Okay, so along with the line, so second part is the energy efficient MTC devices. So design of energy efficient MTC is considered both massive MTC and critical MTC use cases. The efficient design of machine type devices will be enabled through a combination of ultra low power receiver architecture and enhanced energy harvesting technologies and zero energy communication schemes. For example, I can tell like there is a possibility that UEs or devices will be there. Along with the devices, there will be a small gadget will be added. So the gadgets not communicate always with the device. It's kind of in a sleep mode. So our main task is we put the UE, your main device, sleep forever, and we have the small device. So the device, the small receiver's work is to observe the requirements, a request from the base station. If there's a request comes, okay, that's tell the UE, okay, you just get up. There's a work for you. So something like that. So therefore, that's a small architecture that does not have much intelligence, much energy efficient, much energy need. So it works with a very minimum amount of overhead and very minimum amount of data. So therefore, for those kind of cases, there's a different wake up signal design and wake up receivers need to be done. Those are in a kind of a current trend in 3GPP release 18. They discuss about those requirements, and that says it ultra low power receive architecture and MBA backscatter communication for 6G massive MTC. So here's a kind of picture they describe, but it's a kind of very initial stage of the research. So ambient backscatter methods consume significantly less power than typical active transmitters, as no voltage controlled oscillator and power amplifiers are required. So that's a kind of different from the existing architecture. So the deployment for NPM backscatter base stations are like this. So it's in a very initial stage of the research, but I just tell that word you maybe search and find those interesting informations. And energy optimization communication, zero energy and wake up radios, as I said earlier. The wake up radios will be suitable for many cases to control the uh, radios, because the current trend is like there's a possibility that there is a DRX cycle. So every DRX cycle, the particular UE is trying to check, okay, is there any information? Is there any requirements from the base station? If it's not, it goes to the sleep. But for energy efficiency, we can put a very long DRX cycles, but that have the issue. Like, so there's a the request came from the base station within the period. So the device thinks, okay, it's in a sleep, so it's unreachable. Just a minute, there's a two questions. So okay, so there are some forms need to be filled during that meeting. Okay, so that is about the zero energy and wake up receiver. So these wake up receivers are at the moment it's not there, it's in a research domain. Yeah. So then globally massively scalable MTC. To success, the MTC within 6G ecosystem is tiny bounded to capability of offering globally available and massively scalable services for IoT solutions targeting vast landscape of requirements. So here, first one is the frequency regulations. So as we know, there's a frequency regulations. It's there for every countries, and transmit power and duty cycles are permitted. Media access mechanisms are like differ from the region to region. So therefore, when we are going to talk about the global connectivity and global changes, we need to think in some different way. How can we achieve this frequency regulations and spectrum efficiency? And then it's a non-terrestrial networks. Yes, because like now we not only with the base station, we are going to talk about the low Earth orbit satellites, LEO satellites, and drones. High altitude platforms normally see HAP and UAVs to dynamically offloading traffic from terrestrial system to component reach otherwise unserved areas. As I discussed earlier, there can be a critical situation like disasters and all, or sometimes like unreachable areas. So these dynamically allocating UAVs and architectures are kind of suitable for that kind of scenario. So when we are going to talk about the global coverage, first one is the frequency regulations, and then it's a kind of connecting all the devices and all the people. And in the physical layer, this is the kind of main layer, it's the kind of fundamental of designing. So actually I'm working in physical layer design. So it's like non-orthogonal. So in here, there are some technologies are kind of recently started working. So first one is the grant-free access. Okay, I can tell like the current application in 4G and 5G, 4G is mostly like first you if UEs need information or UEs need to communicate with the base station, so it sends some request. Okay, can I communicate? If the base station say okay, you have some slot to communicate, then it sends another request. Okay, then you can proceed. So there are some initial handshaking. So after that, they start to communicate. So that's the kind of general uh, general way at the moment. But for the grant free, it's base stations whenever, so when the devices need to be communicated, so they quickly send the information to the base station. So base station at any time can get the information, the request from the devices, but base station does not know from which device it comes from, because there are no identity, because there if there are identity part or some IDs along with that, then that's a kind of additional cost of information. Therefore the grant free, it removes everything. So therefore in the grant free access, to enable the grant free access, there are non-orthogonal multiplexer schemes are proposed, like normal technology. In the normal technologies, different code books are along with that. So in the code book schemes, for example, SCME code books and Musa code books are they are they are to do the communication. So for example, like SCMA code books are proposed by Huawei, and Musa code books are proposed by ZTE. So likewise, there are many schemes are proposed to do the grant free access. So in the grant free access, the interesting part is the multi-user detection. So when all the requests are come to the base station should have the knowledge to identify them with the code. So those things, there are kind of conventional methods. They are like, but the thing is, there's an efficient method to improve that. So currently, there's a deep learning solutions along with that to improve the multi-user detection. And another one is a CSA free or limited scheme. So like in future massive MTC, expecting there are a lot of devices will be there. So we may have line of sight. There are direct links to the particular devices, so some networks. So therefore, we no need to go for some CSA based channel state information based architecture. There's a possibility to go for a CSA free scheme as well. And coding for short packets. So the codings are the main things for the data transmission. And also LTPC and Polo codes are designed for 5G, and those enhancement will be there for 6G as well. And medium access. So it's a kind of modern random access. So it's grant free, also kind of a modern random access. And there are another defined, the definitions for modern random access also. They are like people start to talk what are the more efficient method than the conventional to the handshaking or even after grant free access. There are some mixed random access schemes also. They are like some part of the time there's a grant based and then grant free. So likewise, there are different resource allocation. So as I discussed earlier, that comes under that medium access as well. And impact on high layers. So impact of grant free transmission on high layers. Of course, when we are talking all the things in the physical layer, that impact will be there in the high layer. So based on that, the final decision will be there in the network. Yeah. Okay, so then I go to the mission critical MTC requirements. So in mission critical, it's like so target KPIs, guaranteed latency, timing tile, and the losses, the block error rates and things are mentioned here. So predictability and determined by the application. It varies with the application. So cost efficient to most challenging and costly. Like So there are some chances, well-planned MTC transmission patterns. So the uniform predictions, traffic pattern will be there. So therefore very cost efficient. But at the same time, there is a very anomaly detection, very random events will be there. So in those kind of things, there will be different receivers architecture to detect and cater those applications. For example, there are some unknown distributions, event driven without any observed predictability. So in that kind of scenarios, the AI and machine learning technologies are required to somehow find those distributions. So so here mention some messages and latency and block error rate for the mission critical MTC scenario as well. So in another picture, it says mission critical management function. It's like dynamically coexistent and resource assignments and pre-activation mitigation of interference and operator independent machine to machine networkers and digital twin of MTC device and networks. At the same time, the resource awareness, monitoring, and prediction will be there. So in this monitoring and predictions, uh, so far there are many massive amount of deep learning based publications are published because like the deep learning have the ability to predict and monitor those kind of real scenarios. Like in that case, the reconfigurable intelligent services also recently introduced around last 2 years. This is one of the hot topic. You may know the base station and the users will be there. In the middle, there's some scatters or something. There's no line of sight. In those scenarios, the reflect intelligent surfaces harm is kind of reflective elements. There's some phase shifters involved there. So based on the phase shifters, so the user can get that some good channel information. Okay, then new antenna technologies. So because as we discussed earlier, so we changed a lot of things from the beginning. So therefore, there's a new design of RF design and the antenna as UAVs and dynamic change SWAM networks comes. So there's a chance like UAV can be a base station and UAV can be a relay as well. So the recombinable intelligence service also kind of a relay architecture, but UAV relay is also kind of in the picture. And that depends on the energy efficiency and the spectrum. There's a resource awareness and monitoring and predictions can be done. So this is a kind of in picture form. Yeah. So finally, about the privacy and security for massive MTC. So privacy and security aspects play a certain role in any communication network. These include anomaly detection and low-cost authentication and data integrity and confidentiality, distributed trust, and among others. So for example, the anomaly detection, for example, we can say the fraud activities and those suspicious things can be done once in a while in the network. So therefore, the network should be aware of detecting those things in a one attempt because they are not going to be the second chance of detecting. So so those are the kind of consideration here. For example, in the privacy through MTC has limited human involvement, but there are some privacy threats that can be identified. So in general, there are related exposures of data releases and individual personal data in many of the identified use cases. For example, as I discussed earlier, um, there are some smart devices and wearable. They definitely have some memory. So those memory have some personal information. If the personal information can be breached and can be lead to a different problems and all. So, for example, in Europe, the European privacy regulation, GDPR still there. So, likewise, I think in future there are some discussions in other countries maybe adopt to the GDPR. So, if so, the network should have the facility to address the GDPR and privacy questions as well. And smart contract DLT, as I said earlier, distributed ledger technology. A smart contract can be compromised transaction protocol that execute terms of contracts. So, as I said, the unmanned aerial vehicles or the transport system, when there is some information. For example, one vehicle is coming one way, and then another vehicle comes from the different road, and the first vehicle does not know the detail of the new road, so it's no need to going to measure everything. So when they met another vehicle, okay, it's asked, okay, can you share the information? If the contact is there, okay, they'll that share the information, and then the processing and data acquisitions will be very low. So then it quickly do the activity. So that kind of applications can be there, and the processing should be at the vehicle. It's not in the centralized place or base station. So the edge processing will be a role for these kind of smart contracts. And the security is only the strong as the weakest link that may change over time. Based on the principle, it is natural to assume the security vulnerabilities may be identified in the life cycle of any system. Therefore, it's a kind of a general requirement. And long-term Scrum data encryption and authentication. In an AI application that definitely need some amount of data. So if there's a data, then the data encryption need to be done. Otherwise, those be taken by someone else. So the conventional, for example, the conventional authentication, authorization, accounting process are neither scalable or cost effective if directly applied to the large number of connected machine type devices. For example, the traditional subscriber identity module, the SIM based authentication solution, it's not suitable for the massive deployment or low power and low cost machine type devices. Yeah. For example, the current eSIM is released maybe because, yeah, kind of in the line with the this technology. So I think currently available new mobile phone can be used the eSIM. So only there's a barcode, so you can, with the barcode you can get the authentication at the same time. So that barcode and eSIM can be activated to mobile devices and smart wearables. So in future it can be expected to apply for the sensor. So in the sensors can be have some identity. So rather than have the physical slot, and physical cost will be reduced, and only the digital identification will be there. So in the conclusion, new wireless technology 6G will enhance future digitalization. 5G service classes, namely URLLC, massive MTC, and EMVB, will be widely adopted and optimized with the further enhancement requirements in 6G. And 6G will introduce new use cases where MTC and IoT will play main roles. There's a requirement for novel design of enabling technologies for 6G. So along with that, if you want further detail of the discussed topics, you can visit the 6gflagship.com. So you can find all the white papers. I think there are 12 white papers published in the area. So in this presentation, I consider only the massive MTC white paper. So if you are interested, you can read those informations. Yeah, that's all. If you have any other questions or something, so
Hi Thushan, can you hear me?
yes.
Yeah, I'm Niroshan. Actually, my background is telecommunication, so I really find it very useful, and really appreciate to initiate such a very useful event. I think this is the first time in Sri Lanka, like, yeah, having such kind of a thing. So it's really appreciate your effort and the support. So my question is regarding this 6G. Like, if you take 5G, we have a concern about the power we are delivering to the environment, right? That's comparing with the legacy network, what we are putting out to the environment is quite high. Like if you say 4G, if you put like 100 watts, but in 5G you are putting out like 250 or like 300 watts. So my concern is in 6G, like when we are going to talk about this MMTC, like then how harmful it's for the environment, then how we are going to echo that confirmation that we are not going to harmful for the environment. That's question number one. And the two is you have mentioned about cell-free technology.
Yeah. Hello. I think you lost your connection or something. Okay, anyway, I'll start answering the first question. Yes, there are some concern about the power transfer as well. So currently, whenever there's a designing procedures involved, so people start to consider standardization, values for the transfer, power transfer. Therefore, as I said earlier, still the wireless energy transfer is still under the discussion because of this power transfer and how it can be adopted. So therefore, the wireless energy transfer still not adapted to 3GPP, still under the investigation how it can be, and what about the energy transfer if it's aggregated together, so what will be the issues and not. At the same time,
Yeah.
for massive MTC devices and environment scenarios, it's not going to be a big issue, because in those scenarios there are mostly machines, and we expect there are minimum amount of human will be there, or sometimes zero humans in the machine, so machines will be do the works and will deliver the output. So in that kind of scenarios, they are not going to be a big issue. At the same time, in those sensors does not have the much power, they are very small devices, so there are not much power transfer, and their data rate is very low. But the thing is, they are in a massive amount. That's the only concern. So therefore, as I know, the 3GP consider that as a one of their main concern about environmental factors, as well as I know in their standards. So what you ask about the selfie, I didn't get the question.
Yeah, I'm sorry. Here was a power cut, so just my connection was disrupted. So I just joined in my mobile. So the self-free, you just talk about self-free technology is going to be 6G. So in that case, like say for example, if you see the operators or the vendors who's going to handle, so it's going to be the network sharing, like say for example, operator X and operator Y, then they're going to deploy this MMTC, then how they're going to handshake and how this communication like interoperator or intervendor, that's going to be the huge challenge, right? So will that be concerned is in the point?
Yeah, actually, the self-free, the interesting thing is there are a lot of researches have been done in the self-free, but still very few of number of the industrial applications start to discuss, because it's a kind of, in a question scenario, because there are a lot of arguments against. There are some positive parts at the same time. There are a lot of arguments against self-free as well. So, like as you say, these questions are still there. So they are thinking how can we address those things in the standardization. So if it's standardized in the 3GPP, then these methods should be addressed. Otherwise, it can't be applicable. Definitely, self-free is not considered for the terrestrial networks, because like if it's a self-free scenario, it's maybe a high interference can be there, and as I said, there should be a full set of frequency regulations and not. So it's not possible practically for the terrestrial normal mobile human usage. So it can be the indoor scenario, for example, indoor base stations there. So instead of indoor base station, the self-free will be there. So that's kind of possible application, because the indoor Wi-Fi base stations, there's the interference and all. So instead of that, just every cells are going to be a one cell, then the interference can be mitigated. So that kind of applications are the possible. But of course, in self-free, there are massive amount of literatures there, but its argument is going on how to implement.
Okay. Just one more question, right? So if you consider this 5G, like we go up to like 30 gigahertz band, right? 30 or 40 gigahertz. So when we go for 6G, then it should be even above than that frequency. So when you go for it, like your lambda and your wavelength is going to be in kind of a millimeter, not even milli, like you can go 10 to the power -6 or -7, I mean 9, something like that. So your refraction and the loss is very huge comparing with the legacy networks. So will it be any special techniques that's going to be followed to get rid of this kind of a thing?
Yeah, exactly. Like even in the millimeter wave, we are facing a lot of challenges. For example, like you may be heard the recent iPhone release, they have the millimeter wave adaptation, but they still facing in New York. They did some experiment. They face the real implementation. So likewise for in 6G, it can be a terahertz communication. So now people researching the beamforming for terahertz. So in the beamforming, they are thinking, end-to-end deep neural network receivers. So it will be the receive architecture, maybe fully changed the deep neural network. So deep neural network, for example, in deep reinforcement learning based beam selections. So that kind of things can be done. Those are in a research direction. Of course, that's a good question because it should be addressed. So the beamforming will be kind of one of the main part for terahertz communication.
Okay, thank you very much. It's really descriptive, and I'm really appreciate your sharing. Thank you.
Thushan, there are some questions in the chat box. Can you please refer those things?
Okay, okay. We have updating our 3G modems with 4G or 5G modems for metering fleet randomly. Right. Okay. So as I understand the question, it's going to be when it's going to be 6G. So as I know, so the expected release may be 2030. The expectation 2030 that 6G releases and also definitely even 6G comes, there is a high chance of existence 4G and 5G because like 4G and 5Gs are kind of designed to support mostly the terrestrial human networks and sensors and also there's a very less chance to remove everything. But of course, 3G will be disconnected. Very high chance 2G and 3G will be disconnected in most of the places because in 3G we are mostly depends on the data rates. So in 4G we can get more high throughput. So then why we need the 3G? So it's a possible we can remove 3G. There are some countries that don't 3G as well. Some part, but very less chance of, in my opinion, very less chance of disconnecting those 4G, 5G, 6G, maybe be together. I don't know after that, but even the 6G releases will be around 2030 period, something like that. So I'll check if there are any other questions. Yeah, okay. There are some questions about the architectures. As I know, those are things in investigation, in the research domain. There are no properly designed architecture because normally the 3GGP standardization will give the proper picture. The recent 3GGP release 18 said about the possible research directions towards maybe 5G plus. Not they start to talk about 6G. So therefore, as I know, I not much know about the complete architecture, but you maybe visit the 6G flagship.com. In the site there are some white papers about the architecture initially, so you maybe check. It may be useful some intuition or some research directions. I think I addressed those questions, so if there are any other questions I can discuss here.
So I hope there are no other questions. Am I right? That case, you'll be wind up the session.
Okay, yeah.
So thank you, Thushan. This was a very short notice, and you have done a very commendable job. I know you that, thank you for the wonderful session. So this is one of the best sessions that what we had in this season. So hope that we'll meet Thushan as Dr. Thushan the earliest. Thank you, Thushan.
Thank you for everyone for the very interesting questions, and also so you can visit the sites and get more interesting articles and all. Thank you. Yeah.
Thank you very much.
Thank you.
Thank you. Thank you.